Dear colleague, sorry, a little technical issue. Welcome to this last day of ITNT conference held in Samara, Russia. I'm talking to you from the European Organization for Nuclear Research in Switzerland, CERN. I would like first to thanks our sponsors, partner, organizing and program committee for this conference. I would also like to welcome our plenary and section speakers, as well as our participants, in particular the young generation of scientists present. And without further ado, I'd like to introduce Professor Leijun Zhang of the Department of Mathematics of Shandong University of Science and Technology in China. She will talk to us about traveling waves, class of higher order nonlinear equations. Professor Zhang is with us by video. Unfortunately, there will be no applause, but please give her a distant yet warm welcome. Please, the video.
I would like to thank the organizers to give me this opportunity to present my work. This is Leijun Zhang from Shandong University of Science Technology, China. The title of my talk is Traveling Wave and Multi-Wave Solutions of a Class of High-Order Nonlinear Wave Equation. Here is the outline of the presentation. Traveling wave solutions are some special kinds of solutions to nonlinear wave equations. They can be usually characterized as solutions invariant with respect to translation in space. They use to describe the process of transmission. Solid wave is a particular type of traveling wave, which was first discovered by John Scott Russell in 1834. He was observing the motion of a boat, which was rapidly drawn along a narrow channel by a pair of horses. When the boat suddenly stopped, the mass of water in front of the boat in the channel didn't stop. It formed the shape of a round, smooth, and well-defined heap of water moved along the channel, apparently without a change of the form or reduction of speed. He followed on horseback. After a chase of 1 or 2 miles, he lost it in the wind of channels. This singular and beautiful phenomenon was named as soliton now. Unfortunately, his great discovery didn't attract enough attention that it deserved, since no one could understand why this phenomenon could happen. The earliest mathematical model of wave on shallow water wave is the KdV equation. KdV equation was proposed in 1895 by a Dutch mathematician, Korteweg, and his student De Vries. For this equation, the exact solid wave solutions can be derived like this. They believe that these strange waves that Russell observed are caused by a cancellation of nonlinear and dispersive effects in the medium. Later on, a lot of model equations are proposed to describe the shallow water wave. For instance, Kamath-Helm equation, Burke's equation, and so on. A number of researchers have been working in this field, and some effective methods are proposed. Here I will introduce the dynamical system method. There are mainly 3 kinds of bounded traveling wave solutions: solitary, kink or anti-kink periodic wave, which physicists pay more attention to. They correspond to 3 types of the orbits of ODEs: homoclinic, heteroclinic, and periodic, respectively. So from this relationship, we know if we want to find the bounded traveling wave solutions, we only need to find the bounded orbits of the corresponding ordinary differential equations. Here are some pioneer works. Professor Ji Binli published the book in 2013, Singular Traveling Wave Solutions, Bifurcation and Exact Solutions, to present related work systematically. For a nonlinear wave equations, which could be reduced to a second-order ODEs, the corresponding planar dynamical system can be given by equation 1. Then, we will study this equation in different cases. First, let's say the case when G is a continuous function. A simpler subcase is that it is integrable system. Like G is a function of f of x, that means G only involves in x. The orbits of equation 1 are determined by its Hamiltonian. In 2002, we started a generalized PC equation and obtained the bifurcation and phase portrait, which are shown here. From this phase portrait, we can see clearly the bounded traveling wave solutions of CP equations. Like for the first case, we know there are 3 families of periodic orbits. So we know CP equations for this case will have 3 families of periodic traveling wave solutions. And for this homogenic orbit, we will know it corresponding to a Sartre wave of peak form. And for this homogenic orbit, we will know it corresponding to a Sartre wave with valley form. And in this case, for this hadronic orbit is corresponding to a kink wave, and for this one, it corresponding to an anti-kink. And this one we know there is one family of periodic wave solutions. If system 1 is a non-integrable system, like for the KdV-Burke's equation, the corresponding system is given like this. And the phase portrait can be these 2 forms. Here we can find that there are 2 bounded orbits which connect the sandal and the foxes, 2 foxes. They corresponding to 2 infinite oscillate waves. For this case, there is a hadronic orbit, which corresponds to an anti-kink. For the second case, if G is not in C, for example, G is given like this. Like if a PDE, the corresponding traveling wave solutions is in this form, then the function G is not a continuous function. These equations are separated into 2 classes. One is if the denominator u doesn't involve y, and the second case is the function u involves y. Please refer to these literatures for further information. The dynamical system to study the traveling waves has its own advantage and challenge. Advantage of this is first we can study the properties and existence of the various traveling wave solutions. It can be recognized very easy from the orbits of their phase portraits. The singular traveling wave solutions of nonlinear partial differential equations with nonlinear dispersion can be studied by this method. The challenge of this method is sometimes it's not so easy to analyze the bounded orbits of the dynamical system, especially for non-integrable system, even for planar dynamical system, not mention the high-order dynamical system. Is it possible to be applied to study the multi-wave solutions of nonlinear partial differential equations. These are the challenge of the dynamical system method to study traveling wave solutions. To address this question, we started a general fifth-order nonlinear wave equations. It gave like this. And for this equation, we say it's a general fifth-order nonlinear wave equation because it includes a lot of famous nonlinear wave equations that is very important in physics. It includes like the KK equation, the Lux equation, CDG equation, and SKDV, SKR equation, etc. And for this equation, we can introduce the variable cases x minus at. Then this PDE can be reduced to a fifth-order ODE. But for this in ODE, it can be integrated once, and after once integration, it can reduce to this general form. And here, G is an arbitrary constant because we integrate once and we get an arbitrary constant. And I also want to point out that here it also involves an arbitrary constant. And this equation equivalent to four-dimensional systems. And for these four-dimensional systems, we know it's not easy to find the orbits. But here, we can use this method to find the invariant. So the main idea is find the possible invariant submanifold in lower dimensional space. Luckily for this kind of system, we can find if the coefficient of this equation 2 satisfies the conditions like D. Here we have D. D is less than or equal to 3 times a squared over 40. We will find that y equals y cos a solves equation 2 if it can solve order nonlinear ODE 3. And here we know the relationship between the coefficient A1, A2, A0, A1, A2, A3, and the A, B, C, D, E, F, G here. The relationship is like this. Here we published this paper in 2015 in Mathematical Problem in Engineering. If you want to see more details, please refer to this paper. And also in Journal of Applied Analysis and Computations. So the bifurcation and exact solutions of the first-order nonlinear ODEs. If we find the solutions, then we can get the traveling wave solutions. And the bifurcation and the exact solutions can be started in 2015. Thus, the traveling wave solutions of the KK equation, Lux equation, CDG, SK, these equations can be derived. And this idea, just like I mentioned, the main idea is find the possible invariant submanifold in lower dimensional space. And if we couldn't find all the solutions in high dimensional space, then we find the possible invariant submanifold in lower dimensional space. Here is the main idea. So the same idea might be applied to study the traveling wave solutions of nonlinear PDEs, which even can be high order than fifth order. Like the only condition is if this PDE can be reduced into this form, the ODE only involves U prime square, U double prime, and the order of even order. If in this form, so the same method, same idea maybe can be used for this kind of nonlinear wave equations. Next, I'm going to introduce how can we use this method or this idea to find the multi-wave solutions of KdV SKR equations. The KdV SKR equations given by this. Here it involves two parameters A and B. And for this equation, it can be written in a weak form. And for this equation, we introduce two variables, independent variables, Xc1 and Xc2. We introduce Xc1 is x minus c1t, Xc2 is x minus c2t, and we let u equals capital U Xc1 plus V Xc2. If we can find a suitable C1 and C2, C1, C2 we call it wave speed. If we can find C1, C2 and find the solutions in this form, we call it two-wave solutions because it has two speed, C1 and C2. After we introduce this U, capital U Xc1 and V Xc2, then this equation can be reduced into this form. Now let us look at equation 6. You will find that each of the four brackets only involves U or V. Here, U, here involves V. We specially organize it in this form. Then we can see if each term inside the bracket is 0, then the sum will be 0. That is to say, if U and V satisfy equation 7, then they solve. Now let's say how can we solve the system 7. 7 are two systems, but the two systems are symmetry. If we change U to V and C1 to C2, F1 to F2, then we will know that the two systems are same. So if we can solve one system, then similarly we can find another one. Symmetry, if we can solve for U, then similarly we can solve for V. For the first system, we find that if the two constant F1 and F2, if it satisfies this equation, that is, if we choose F1 and F2 like this, U Xc1 satisfies the first equation. This is a second order differential equation. Then it shows the second equation. That is, it shows the whole system. So we use this property, then we can solve this system 7. And we get this theorem. It is U Xc1 and U Xc2 and V Xc2 satisfy equation 9 and 10 respectively. Then U capital U plus capital V solves the KdV SKR equation. This is the main theorem. We know equation 9 is a first order nonlinear differential equations. By the bifurcation analysis, then we can find all the solutions of equation 9. Similarly, we can find the solution of equation 10. The equation 9, we find the exact solutions U1, U2, U3, 4, 5, and 6. Similarly, we can find V. We can find V1 to V6. After we get the solution U and V, then we have the theorem on the exact solution of KdV SKR equation. That is, this KdV-SKR equation admits the traveling wave solutions UIG. It's a sum of capital UI plus VG. Here UI and VI are determined by the solutions, the formulas we just presented. And C1, C2, that is the wave speed satisfied two conditions. We use the numerical simulations to plot the graph of these exact solutions. We get there are three kinds of solutions. The first one is U and V. If we choose U and V as solitary wave, we get the solution is like this. The second graph, we choose U and V are periodic wave. And the third one, if we choose one is solitary solution and another is periodic, then we get the solutions of this. So by this method, we get plenty of traveling wave solutions. Here are the two-dimensional portraits of the two waves constituting of two solitary waves. We can observe the interaction of the two solitary waves clearly from these portraits. And this one is the two-dimensional portraits of the solution constituting of two periodic waves. And this one is the portrait of the solution constituting of one solitary wave and one periodic wave. Let us make a conclusion of this talk. We can get bounded of traveling wave solutions, even multi-wave solution, to a class of high-order differential equation by using the lower dimensional invariant manifold and bifurcation analysis. I believe this method also can be applied to study other high-order nonlinear wave equations. Thank you so much for your attention. Please contact with me by email if you are interested in this topic. Thank you.
Thanks a lot to Professor Zhang for this very interesting presentation. Unfortunately, she appears to be having some troubles with connection. We will therefore have to take the question in the chat, so please feel free to ask the question, and we will come back to you as soon as we have answers, and we will, of course, forward you the answers. So we now have a few minutes, and I can ask already the next speaker to prepare themselves. We will now welcome Nestlé Russia, Samara branch, Sergey Anatolievich, which is head of IT department there, Kirill Leonidovich, process and optimization manager in the same place, and Vasily Viktorovich, digital market lead. They will talk to us about the latest implementation of IT technologies in their industry, in particular the challenge of digitalization of continuous production. Before we welcome a Nestlé representative, just give a couple minutes so people can ask some question in the chat, and afterwards the floor will be to Nestlé. Okay. So, of course, you can keep writing, and we'll take in account all comments that you will be writing in the chat. And now the parole is to Nestlé. Thank you.
Okay, hello everybody. My name is Vasily Dolgov. I will be the one of the speakers today, and here is Kirill.
Good morning.
So Kirill is gonna share the presentation, and we will be three of us who will participate. Later on, one of our colleagues, Sergey Dolgov, will join as well during the presentation. So Kirill, could you please share the screen?
Already.
Okay, just a second. Я не вижу. Okay, just a second, I have to find a screen.
Colleagues, can you see our screen with presentation? Please write in chat if you do. Oh, thank you.
Yes, I can see. Can you please put on the, this is the first slide, okay. So colleagues, we would like to talk about, let's say, practical application of some IT and digital solutions in operations. But first of all, we would like to say a few words about Nestle company. So as you probably already know, Nestle is one of the biggest food company in the world. So on this slide, you can see, let's say, the spreading of the sales within the whole market and the key categories where we represent our products. As you can see, confectionery is a quite small part. So we're currently talking from Samara factory branch, which is mainly producing chocolate products and also beverages. Yes, if we're gonna talk about Nestle Russia and Eurasia in general, so it's quite a big amount of people working here, and we have 11 countries under this let's say umbrella Nestle Russia and Eurasia, and we have 8 factories which are mainly located, not mainly, but all located in Nestle Russia, in Russia. So I will pass the word to Kirill. He will explain a bit more about situation and let's say some details about Samara, and then later on I will come back.
Hello everyone. So Nestle's Samara factory is well known in Samara region and outside as well. And I would like to mention that our factory is the factory of the full cycle from cacao beans to the finished good product. This year we're celebrating 50th anniversary, and during all these years, delighting of the consumer with high quality of the product is the key goal for our company. Due to current pandemic situation, we postponed the celebration of this great event with purpose on keep the safety of our employees and our consumers. And speaking about this new reality, new pandemic situation, it's forcing us to look through the new safety barriers. And beside the all well-known recommended actions that we are focusing on right now, we're also focusing on new ways of working. And one of the new tools that we are implementing recently is infrared camera. It allows us to measure temperature of our employees on social distance on main entrance of our factory and avoiding the queuing with special noise signal in case of high temperature of somebody in the line. Also, of course, this situation is affect our office daily routine work, and using the Office 365 tools, we conducting our operational reviews and meetings in remote way. Currently, we able to manage over 60% of our office workers on remote mode. In case of worst scenario, we are ready to go over to 95%. So these tools are really helpful in this particular situation that we're facing now. And of course, not only these tools we are using, we're also using the Power BI, Power Apps, SharePoint, and all the rest of Office 365 tools that is available. It's helpful for operations to make it sustainable and to connect our team members in an easy way. So, Vasily?
I would like to talk about digitalization in a bit more details. So on this slide, you can see a picture in the green one, which is, let's say, demonstrating the way of working of some companies or maybe some people. What this picture represents, it demonstrates that sometimes people are spending almost full day on their daily routines, on their daily tasks, and sometimes on firefighting. Yes, so it means that there is no time and there is no, let's say, available possibility to start thinking about something more interesting, about something more strategic, which will improve situation, improve efficiency of the company. So I think that everybody wants to be not in before picture, as you can see on the bottom, but we want to be in tomorrow. So when we have less firefighting, almost no firefighting, I would say, in daily works, they are organized in a very well approach. So Nestlé is considering that we are over here on this white line on this green picture. So when we have almost no issues and we have some time to do some strategic things to work on processes improvements and so on. So that's why how to reach this situation when we are, let's say, working in comfortable conditions. Now let's please move back again. Yes, thank you. Of course, it's not the, let's say, one-time activity to work effectively. We have to do a lot of job for this, and one of the way to make it happen is processes optimization and also finally digitalization of these processes. So in this picture on the right side, you can see, let's say, the first phone or almost the first phone and the phone now. So the word is the same, but the meaning, I would say, already different, and functionality is already different. That's why it is significant to work in modern way effectively. And then please move to the next slide. If we're talking about, let's say, directions, when we're talking about digitalization, it's maybe not the, let's say, the only categorization, but nevertheless, so we have to talk about connectivity, intelligence, and automation. So talking about connectivity, it means that we have to connect people to provide them right information in right time, in full, with good quality. And this is the one direction where we're working on. Then we're talking about intelligence. It is a, well, let's say, quite a wide range of activities which needs to be investigated and applied. And here we are talking about some things like demand forecasting, digital management systems, and so on. And also automation, here we are talking about application of solutions like cobots, AGV system, and many, many others. Let's switch to another slide. And it was like a general, let's say, overview. And if we are talking now specifically about Nestlé, and not only Nestlé in Samara, but wider, so we are working in all these three directions. So talking about connectivity, we do use some portative devices like smart glasses, tablets, which are really helping us to do daily job fast, effective, with no paper or with, let's say, minimum amount of paper, which is kind of an indicator of the processes which are not really effective enough. So another area which Kirill have already mentioned, it is a usage of Microsoft Office tools. This is the really big area where we want to go deeper, where we want to learn more, because these tools are allowing us to build our own, let's say, applications which simplifying the way of our work. of course, this is not all about connectivity, but nevertheless, I will leave it as is. So talking about intelligence, here we are talking about digital manufacturing operation system, and Kirill will talk about it a bit more. So it's a kind of a special system which we are which we are installing now at Samara site, and not only. We also here talking about predictive analytic tools, which helps us to predict when the machine can break, how to eliminate this, and how to maintain the machine in basic conditions in order to prolong its life life cycle. Also, we're talking about automation, and here we're talking about AGV system and cobots. We are not going to let's say demonstrate all details for all these topics, because it spread it between different factories and even sometimes in different countries. It nevertheless is demonstrating that we do work and trying to be modern. Another area which we also just stepped in, it is a big data analytics. We have a lot of data to analyze, to improve our processes, to make a deeper processes mastership. Okay, thank you. And then I pass the word to Kirill.
Okay, for every continuous production cycle, there are critical key performance indicators which should be tracked on different levels of operations. Among them, performance of equipment, quality of product, net weight of our finished good, and energy consumption of our line. In Q2 2020, we implement new software for production cycle control called Digital Manufacturing Operations, which cover all these aspects on pilot line. The software is collecting data from PLCs on machines and provide relevant necessary data online to shop floor, line leaders, and factory leaders on one click. We plan to roll out this software on all the rest production lines during this year and next year as well. So what it brings? As a result, we're improving the daily routine in all levels of operations, eliminating papers and back office work, and give the possibility to our employees to focus more on process mastership instead of the firefighting and double reporting. And speaking about the papers, it's a really big amount of papers signed and fulfilled by different departments. And another big project that we launched to attack it is IMM Mobile, which mostly aimed on engineering department. So what is IMM Mobile? It's asset maintenance management system. This is software for portable devices like tablets or smartphones, which provide us with possibility of eliminating printing and signing work orders from SAP. Before, it was necessary for every routine or minor maintenance activities conducted on the line to print it and to fulfill it by hands manually. Nowadays, we start using tablets with this software without filling papers, and we do it online. Another portative device which we are using is smart glasses. It allows us to connect our third-party specialists or subject matter experts directly to shop floor in case of some critical troubleshooting, or in case of training which should be conducted definitely on some areas on the production. It's really a helpful tool, again, in this current situation, and we're starting to use it more and more. So I will give the word to my colleague Sergey Dolgov, IT specialist. He will speak more about the hardware part and SCADA systems.
Hello, everyone. I'm Sergey Dolgov. About screen display, an important part of digitalization of display and management of information. We use Rockwell Thin client, Rockwell Thin Manager software. It's based on our servers. Through this system, all data can be output to the TVs, monitors, and other devices, for example, PCs. and also we use this system for deployment SCADA system to organize controlling of process. Totally, we use one control point based on our service to display all data and organize process control through Rockwell Theme Manager. Next, please. Most digitalization projects are based on our company servers. During the launch of digitalization project, the number of our servers based on factory it was be 9 servers. After starting this project, it was decided to going to virtualization technology. At the moment, we have around 51 servers based on 2 separately platform, Hyper-V and VMware, disk shelf storage and 3-part storage. We use it as storage technologies. What virtualization give us? Increased ability to external factories and redundancy. Sorry. Erase easy of management service and easy of management service resources. Very important. It cost of each service. The cost of each service is falling with increase of all virtual service. The table below contained an approximate calculation about cost of each service. In this case, if we use the virtualization technology, it justified if we have 20 and more servers. To ensure the stable of this system, it's necessary to at least to provide a good network, and we need provide good network bandwidth. It's described. Oh, sorry. It's necessary to use a fiber optic communication. For future, we plan to move distribution infrastructure. Each host and storage will be located with separately server rooms. In case if we have failure of host or storage of loss of server rooms, it will not affect its performance and for technology process and for factory totally. Next, please. This slide show us example of virtual management console, Hyper-V and VMware, what we use in the factory. VMware is more advanced environment than Hyper-V because it's great opportunities. It's more professionally. Thank you very much. That's all.
So, speaking about next topic, I would like to go on Russian and want to address our students. Коллеги, добрый день еще раз. Хотел бы вам рассказать немного о инициативе, которая есть в компании Nestlé. Она называется Nestlé Needs Youth. И эта инициатива, она направлена на молодых специалистов, которые сейчас заканчивают университет или же планируют проводить свою производственную практику. Мы очень заинтересованы в том, чтобы эти молодые умы с свежими идеями пополнили команду компании Nestlé. Поэтому ждем вас у себя. Вы видите контакты, по которым вы можете адресовать свое резюме. И ждем вас в команде. Также хотелось бы рассказать о истории успеха. С радостью делимся историей успеха Андрея Пушкина, который закончил аэрокосмический университет, ныне Самарский национальный исследовательский университет имени академика Сергея Павловича Королева. После того, как он закончил этот университет, он в 2003 году устроился в компанию Nestlé и сейчас является главным инженером и руководителем технического отдела. В связи с этим еще раз приглашаю вас всех поучаствовать в этой инициативе. Очень ждем ваши новые и свежие идеи и ждем вас в компании Nestlé. Спасибо.
Я хотел бы немножко добавить и подчеркнуть, да, что так как мы говорим о том, что компания Nestlé стремится быть современной и является таковой, тем не менее нам очень интересно пообщаться, увидеться и, да, и, может быть, начать взаимно сотрудничать с коллегами, кто хорошо владеет навыками разработки каких-либо решений, вот как раз, наверное, в большей мере связанные с connectivity, но не только. Поэтому наши двери открыты, готовы для любых встреч, для собеседований, для подобных конференций. Спасибо большое, и теперь we are ready for questions and answers.
So, thank you very much. Thanks for your talk. It was very interesting opportunity you offer to young researcher to join your company. First of all, I hope this will give, in particular to students listening to us, good overview of technologies used in the industry. So now, indeed, we have a nice bit of time. So please, if you have questions, address them in the chat. And well, since it doesn't seem that we have a lot of questions that arrived yet, I might have one.
Okay.
What would you say the global situation with COVID really changed in terms of development of new technologies? Do you have some new projects that came in specifically relative to the situation or for safety, for example? I don't know.
Yes, as Kirill have already mentioned, that a lot of different activities, let's say, were implemented on the factory, not only in the factory, but also in offices and everywhere. But this is more about the way how to protect people. If we're talking about some, let's say, really digitalization projects, then we started to widely use tools like Microsoft Office Teams for calls, for video calls. We widely using smart glasses, which is, let's say, a very modern thing to, which is allows us to make some installation of new equipment. For example, we have some projects which require support from suppliers, and usually they are able to come to us, but now within the current situation they cannot come, but we have to install this equipment, we have to set it up. That's why we are using this remote support in order to do it. I think that this is a, let's say, key changes which we are having now, but and also, as Kirill have already mentioned as well, that let's say majority of people in offices, they are, let's say, working from home, and this is quite effective nevertheless. It is a new way of working really, and we still remaining effective, and we are effective. So I don't have in mind now any, specific example of the project, but what we really understand that the future will be already different when the COVID will end, and I think that we will use more and more such tools like Teams, like tablets, all these things, because it really helps us to do job remotely with no loss of any effectiveness. And we already agreed with some suppliers or some producers of equipment that in the future we will still continue using this approach, even if they're able to come, because it is faster, it is cost effective, and this is the lessons, let's say, learned so far.
Okay, thank you very much.
Mm-hmm.
So I see we have now other question from Alberto Di Meglio. So I'll read it for everyone. Can you talk about the predictive maintenance activities, and do you use Internet of Things networks, so IoT networks, or how do you collect and then analyze data?
Okay, thank you for question. I think that my colleagues can, for example, Sergey can comment on Internet of Things, but if I'm not mistaken, we are, at least in Russia, not so, let's say, widely using these things so far. But if we are talking about data collection and how we work with this, so that for data collection, we are using historian servers. And then based on this, we have different tools to analyze it. And for example, now we are investigating possibility to use such tools like Trend Miner and Breakcube, big data analytic tools, which allows us to deeper understand our process to find correlations between different parameters. I think that's my answer. Colleagues, maybe Sergey, I will quit, and then Sergey maybe comment on the way how we collect the data in more details.
Oh, hello again. About Internet of Things network. Network will be created till the end of this year because we have some issues with settings and safety networks and special brand malwares with checkpoints. Now we testing this and setuping. How do you collect and analyze data? I agree with Vasily. We use Wonderway with Wonderway software, Wonderway historian with the virtual servers, and analyze as say Vasily, we plan to use Braincube and we use special software from Aveva company for analyze data and management. Thank you. Do you have any questions? And if I can more say, please say me.
Okay. So thank you very much. I see there is one more question from Maximilian Ilyich. I'll translate it to English, or I'll do my best to at least. So which big companies would you be working with to develop your project, or which companies in general? Or do you develop the solution mostly internally, or well?
Okay. So let's say our main let's say set of tools which we are using for internal solutions which we developing. This is Microsoft Office. Let's say all set of tools which is within this. If we're talking about some other companies like external companies who are providing support to us, the main one which which we widely use is ERP system based on SAP. This is the one of the biggest one. Now, as Sergey has mentioned already, we are working with Aveva and with Wonderware, and we're also working a lot with not new companies, but the companies which are providing, let's say, leading technology at the current moment, like Cognex cameras to recognize some let's say defects in ingredients or in products, and many others. So it's a huge list of third-party companies which are providing support for us. That's why it's hard to mention everybody.
Mhm. So it's mostly external company. You don't really have a developer pool in your branch.
This is one of the objectives which we're really having, because we would like to have our internal resources to build solutions. We already have made some steps in this direction, and we have on average site we have at least digital leads, like champions, and they are having teams. I mean, the team with which they are working with, and yes, this is the area where we want to grow further, to develop our competence to be able to create whatever we need by ourselves.
Okay, so that would be an interesting lead actually for the students you were talking about.
Exactly. Yeah, exactly.
Right. Okay.
Yes, and Sergey have mentioned yes, some extra
companies. Okay. I suggest I'll leave a few more seconds in case there is one more question, and the next speaker can start preparing himself. I'll of course introduce him.
Okay.
So.
In any case, if you will have any questions, please send it to us. We will be happy to answer.
Okay. Yes. Thank you. I want to specify that you've put your email, contact email from HR in the chat. If you want to leave your personal contact information, you may also do that, I suppose. And that should be all.
Yeah. Okay, then. Thank you very much. I'm leaving.
Thank you very much indeed for this talk, for those very good, very enlightening answers to the question, and for your participation.
Thank you.
So next, I would like to introduce to you Dr. Alberto Di Meglio. He is head of CERN Open Lab. So CERN Open Lab, it's a CERN section through which the organization develops really cutting-edge solution in the field of information and communication technologies. So the organization's focus includes data center technology, machine learning, applied breakdown prediction that is presented in a section talk of this conference, and the last I would like to mention, but not the last in the portfolio of Open Lab, is quantum technologies, which Dr. Di Meglio will now tell us more about. So I'd like to give the floor, or okay, I'd like to give the screen in this specific case to him and to his quantum technology initiative at CERN. Alberto?
Yeah, good morning. Can you hear me?
Yes, we can hear you.
Yeah. Okay, perfect. So, good morning. Thank you, Ian. Thank you, the dear organizers of this conference, and dear colleagues. I was actually here, I was actually attending this conference a year ago, physically in Samara. I was very impressed by the quality of this event. So I'm very happy to be back, although just in a virtual form. So last year we had the opportunity to discuss about the collaboration that we have with Samara University. And actually, our chairman today is the principal investigator of our joint project that has to do with optimization of the operations of linear accelerator systems. So very interesting. But this year I would like to talk to you about our ongoing research program in quantum technologies. So quantum technology is a rather recent field of research, relatively recent. the term quantum technology was actually introduced not more than between 10 and 15 years ago, very experimentally. But it's becoming very, very rapidly a very interesting field of research, but also of actual applications. Now, this talk is mainly about the current investigations going on at CERN, but I would like to give you a bit of an international context for this research. So, what do I mean by quantum technology? So, in general terms, there are 4 areas that are considered when discussing about quantum technologies. The first one is quantum computing. The second is quantum sensing and metrology, measurement instruments. The third one is quantum communication networks. And finally, a more theoretical aspect of quantum system simulation and information processing. So these are the 4 areas that in general are referred to when talking about quantum technology. There are a few more aspects or integration of these different aspects. So quantum computing is probably the most advanced today, but very interesting research and application activities are going on also in sensing, communication, and in quantum system simulation. So what all of this has in common is the fact that they exploit quantum mechanics effect, like coherence, superposition, and so on and so forth, to actually produce some effects that are not possible to produce in more classical terms. Now, why the acceleration? Why now? So this is driven really by quantum computing, mainly quantum computing in terms of both application software and in engineering aspects of quantum computing. So here you have a chart of different trends in quantum computing devices, different technology, and you can see that the trend is growing. Depending on the technology, it grows more or less faster, but is progressively increasing in a very interesting direction. And in the past, let's say 2 to 5 years, so the interest has moved from the purely academic research into applications. There are many companies worldwide that are putting efforts in designing quantum computing devices, and also a lot of very interesting funding opportunities for research and development have appeared almost everywhere in the world. So it is a very high potential, and the opportunities for doing very interesting research are becoming very concrete. So this is a sort of map of the richest initiatives and investment worldwide. Europe has established about 2 years ago a quantum technology flagship program of the order of around 1 billion euros of investment. The same is happening in the United States from the DOE program, so the $1 billion initiative that is establishing quantum technology research initiatives in the main national laboratories. Same in Australia, in Japan, in Canada, and of course the same is happening in Russia. So as part of the digital economy national program, as far as I know, there is a specific line of research for developing the Russian quantum technology roadmap that has the same level of funding, about the equivalent of 1 billion euros out of the 26 billion euros that are being invested in the national program. So all countries everywhere in the world are ramping up their investment and interest in this. Now, specifically for CERN and in Europe, in the European CERN member states, of course, similar initiatives are taking place, and there are many collaborations that are being established in collaboration between public and private initiatives, so between academia, universities, research labs, and companies, industries. And as far as CERN is concerned, this has started in the IT department in CERN Open Lab, which is the unit that I'm responsible for. We have started a program of investigation of quantum technology, especially quantum computing, about a year and a half ago, and we are looking into the future roadmap for future development. Now, about a year and a half ago, we organized the first workshop on quantum computing, quantum technology for high energy physics at CERN. It was a very interesting event. It started very slow, so until a few weeks before the events, not many people had registered for the event. So we sort of thought that the interest was not very high, and then suddenly there was an explosion of interest and registration, and we ended up with more than 400 people attending these events over 2 days, and both coming from both academia, universities, and industry. So the event was very interesting. We identified a number of opportunities for collaboration and research relevant to high energy physics, but in general to various scientific domains, including computational chemistry, material science, and also, for example, finance or transport. So we have started a number of pilot projects, especially around quantum computing, to investigate a bit how this technology works and what are the technological trends that we can see for the future. And the idea now is to move from there into a more concrete research roadmap for the next few years. So I would like to give you some examples of what we are doing today. And this is specifically focused on quantum computing, which is our main interest, but I will give you also some information about the other areas. So what is our interest in quantum computing? So of course is to understand what is the impact of quantum computing devices, hardware, and also the software aspects of quantum computing on the research program of the high energy physics community. So the potential we are looking at is essentially in terms of accelerating the computing activities. Today, CERN is an international collaboration, and the computing aspects are extremely relevant. We have many different types of workloads, as we call them. I will give you a few examples, but we go from simulation to data analysis, data acquisition, and so on. And in order to make these investigations more precise and to scale them up to larger systems, we need very performant computing infrastructures. And we are looking into various types of accelerators, not only classic accelerators, of course, like GPUs, TPUs, IPUs, or this dedicated to machine learning and deep learning algorithms, but we are looking also, of course, a bit into the future, into what are called non-von Neumann architectures, so neuromorphic or quantum computing devices. So our interest in quantum computing is to start building skills and experience, try to understand what is the gain, the advantage in terms of acceleration of our standard computing models. So we would like to set up a distributed quantum computing infrastructure composed of both simulators and hardware, so that the community can actually design algorithms and understand how this works. And the idea from a practical point of view is to take different examples of the physics experiment computing models and transform them into their quantum version, and then benchmark the quantum version against the classic version and see what are the potential gain in computing acceleration. And one of the most interesting challenges today is that the software development tools and the stack of middleware between the hardware and the applications are essentially not existing. This is a completely new way, new field of investigation, and both from the scientific but also from the engineering, the software engineering point of view, there is quite some very interesting research to be done in the coming years. So these are a few of the companies we are talking to in order to implement our strategy. We are discussing with companies like D-Wave, IBM, Google, Rigetti, Intel, Microsoft, etc. They are all developing prototype computing hardware devices based on different technologies, going from ion traps and superconducting qubits to more silicon-based type of qubit gates, topological qubits based on more or less still theoretical special exotic particles like anions or silicon photonics. So all these approaches are advantages and disadvantages, and we are trying to understand how they potentially work or will work in the future. And we are also talking with a number of companies developing software and tools for developing applications on top of quantum computers. So examples. This is just a very quick reminder of the type of computing workloads, investigations that we use in high-energy physics. So it goes from data acquisition close to the physics detector into track reconstruction, so which is the part where all the signals coming from the data acquisition sensors are transformed into digital information, into particle tracks for that make up the physics collision events, into data analysis, which is the actual exercise of looking at these digital tracks and understanding what was the physical process, the physical event that happened at the very beginning inside the detector, with the hope of finding new physics and new particles, new phenomena. And there is an important part of simulation in order to understand whether what we are looking at experimentally is understandable. We need to simulate those events first using theories we know of, and then we compare simulation and analysis, and we try to understand whether we found something new. So all of this has a potential improvement by using quantum computing technology. So the first example is application of quantum deep learning, so specifically quantum generative adversarial networks. So generative adversarial networks are, again, a fairly recent approach, typically coming from image analysis, but it has become a very interesting simulation tool. The idea is to take an image of what happens inside a detector when a particle collides and cross the detector, and then use generative adversarial networks to produce very sophisticated, very realistic, but simulated images of what happens inside the detector. So this would replace in time more traditional Monte Carlo simulations, which are very precise but very time consuming. So typically Monte Carlo simulations take around between 15 and 20 seconds per particle for simulation, and we are talking about millions and millions of particles. So it takes really months to generate precise images using Monte Carlo simulation, and a lot of resources. With a generative adversarial network, this could be potentially reduced by a lot. We are talking about 3 to 4 orders of magnitude speed improvement using classical generative adversarial networks implementations. And we are looking into their quantum counterparts, which would produce potentially additional orders of magnitude of improvement. There are two approaches we're looking at. One is more discrete, is a qubit approach using a standard conducting gates using a model developed by IBM, which is giving very interesting result. You have a graph here of the comparison between the real data of the energy dilution of an event with an histogram of the simulated quantum GAN distribution, and you can see that there is a very good match, even using few qubits. The problem with this approach is that it is discrete, so it can be used to simulate the energy profiles, but we need to simulate more than that. It's not just the energy profile, it's also the relative position of the particle and the phase shift when they cross the different sensors. So we need a continuous variable approach, which instead of using superconducting gates is more suitable for example, for photonic quantum gates. This is again very experimental, but very interesting, and the potential here is really fantastic in a timeline which goes in the next 5 to 10 years. The second example is the speed up of combinatorial searches for track reconstruction. So track reconstruction is the exercise of understanding how the different coordinates generated by the sensors when a particle crosses them actually can be aligned to produce the real image of a particles crossing the detectors. And it is a very computationally intensive exercise that starts from identifying what we call the seeds of the tracks at the center of the detector, and then propagating their dynamic properties using Kalman filters. This could be replaced by a quantum version that uses a quantum approximation algorithm to find the optimal seeds, and then using variational quantum eigensolvers to optimize the Hamiltonian of this system and find the optimal seeds for this tracking. And then once the seeds are found, then it might be possible to use a quantum version of graph neural networks to actually find the tracks without using Kalman filters to move from node to node, but using again an energy optimization strategy to find the best graph representing the final state of the tracks. So again, all this is very experimental. We are doing this on very few hardware qubits and a bit larger software simulators, but the initial indications are extremely promising for the future. Same thing for classification. This is the final stage, and we are looking into quantum version of standard classical machine learning approaches, like, for example, support vector machine to find to identify, to classify particle events. In this case, it's an example of the identification, the classification of a particular Higgs boson decay channel. And you have here an interesting graph, preliminary but already quite interesting, of comparison between classical boosted decision tree approaches and the quantum version on both hardware and quantum computing simulators. And you can see that they are already very close, despite using a very limited number of qubits and the necessity to introduce, for example, approximations in the number of dimensions we can analyze. And we need, for example, to use a principal component analysis to reduce the dimension of the system in order to run it on current hardware. But still, the approximation is still very, very convincing, within 10% from the real classical values. Now, this is about quantum computing. In terms of quantum sensing, also the research is very promising. It might be possible to use new type of ion traps, new type of decay and entanglement effects, using, for example, small quantities of antimatter instead of matters, to produce very sophisticated, very precise sensors with application not only in detectors for high energy physics, which could be very relevant in the search for dark matter, which is the next frontier of high energy physics research, but also for research in computation in chemistry or in material science. So this is the very beginning of our research, and the plan is to introduce a more concrete research roadmap for the next 2 or 3 years. And in terms of quantum communication, finally, this is something on completely different aspects of quantum application. In this case, the idea is to use special encryption techniques using a protocol called quantum key distribution that would allow to produce very secure communication networks. And secure in this case means that since the protocol uses a quantum entanglement, as soon as the information is tampered with, if someone, a third party, tries to intercept the communication, then because of the nature of the quantum entanglement, the information would be destroyed. So this network would allow to transfer secure information, for example, personal information for medical applications, in a very secure manner, preserving the privacy of individuals and allowing to extend to larger scale current medical investigations. And given the current medical situation in the world, we have realized collectively that having the possibility of scaling up to big data medical investigations in a very secure way is probably needed, not only today but also in the future. And CERN is today part of the initial investigations to deploy more general secure networks based on quantum key distribution. So how would this be implemented? So this is an idea of what we would like to do. The idea in the future for the next 3-4 years is to implement this as a research program in collaboration with the CERN member states and the countries doing research with the physics experiment, but also with the industry and national and international research initiatives to advance the research in all 4 areas of quantum technologies, in sensors and detectors, in computing and the engineering aspects of quantum computing, in communication, and in the theoretical aspects of quantum system simulations and information processes. So this will be based on academic type of research with a doctoral PhD level program in all areas, again in broad collaborations with all national and international activities. So again, I would like to send a message to all young researchers looking into machine learning, deep learning, artificial intelligence, and quantum machine learning, and or more hardware aspects of sensors and communication. This is something that will produce a very interesting field of research for the coming years, with extremely interesting opportunities for research and real applications. So we are really interested in discussing with young researchers and young talents to work on this together. So this is the end of my presentation. I thank you very much. As I said, it is a great pleasure for me to present our work in this conference, and I really hope that if you want, if you still agree to have me next year, we could do this in person, and I will have the possibility of enjoying your great hospitality and beautiful Samara. Thank you very much.
Thank you indeed, Alberto, for this great talk. Very instructive, definitely state of the art. Well, I can't talk for the committee, but I'm sure that you will be more than welcome to come again. So yeah, I see we already have some questions. I'll read them out loud in order for everyone to hear it. So yes, one of the questions was related to what you just said. So how to join Open Lab for students and companies?
Yeah, so I can distribute, of course, all the necessary links to our website and the different programs. There are many opportunities. So for students, for example, we go from a short internship for summer student programs that last a few weeks up to PhD and postdoc collaborations over multiple years. So there are opportunities for students at all levels to join our research programs. And for companies, it's the same. It must be clear that our work is not at a commercial level. It's really research and development. So companies are very welcome to join to establish common research programs. And actually, we are very happy if companies invest in this joint research by providing us with grants for students. This is the mechanism. So most of our young researchers are co-funded by academia, by CERN, and by companies with which we have research programs. So there are many opportunities. I will distribute the links.
Great. So I can confirm, as I just fall under this category, actually.
As I mentioned, so Jan is the principal investigator of a program we have in collaboration with Samara, and he can tell you all about the experience of working with Open Lab and with me.
Absolutely. I'd be happy. I will also share my mail, so if you have any question, you can contact both of us. So another question was, so I think it answers also the question from Alexander, which was, is there an opportunity to do PhDs at CERN? So yes. Who you collaborate with for those experiments was the next question.
So it depends what you mean by experiments. You mean for the examples I've shown, I guess.
Yes.
Yeah. So each of those examples are done in collaboration with different entities. So I can show you very quickly. So so for example, I mean this for the GAN experiment, and I can also answer the following question. There is a question asking me if we have our own implementation of GAN or what we use. So this the QGAN implementation, the QGAN work is done is based on the IBM implementation of QGAN for the discrete model. We are developing our own implementation of the continuous GAN approach. We are using existing sensors like strawberry fields, and we are discussing with a company developing silicon photonic qubits for the continuous variable approach. Again, I can distribute more details on the implementation, and there are a couple of papers or presentations that I can share describing the work. And the other experiments are done in collaboration with experts from the high energy physics experiments. For example, the track reconstruction is done in collaboration with CMS. The quantum graph neural network is done in collaboration with the Middle Eastern Technical University in Ankara in Turkey, and with GluonNet, which is a no-profit organization in Switzerland, working in many European countries. For the quantum machine learning, we are working with Atlas and Wisconsin University, but this is done on IBM hardware, so it is a collaboration directly with IBM. This is probably I skipped this, but this is an example of hybrid reinforcement learning, which is done in collaboration with Alex Experiment and with the D-Wave. It's an implementation for the annealer type of computer. Of computing devices. So we have collaborations. We try to collaborate with different companies to test as much as possible all the different technologies.
Great. I think that's definitely answered the question. So I think we just have time for one more question, if you don't mind. Which was Pavel asking, do you have your own implementation of GAN? Or which GAN did you base yourself on?
Yeah, this is what I mentioned. So for the discrete implementation, we are using the IBM implementation. And for continuous variables, we are developing our own based on strawberry field simulator.
And then the strawberry field, you know, the approach.
Strawberry field is an open source simulator. It's not our own implementation. It's something. Again, I can distribute links. There is a very interesting link I can distribute. There is actually an inventory. A person has made an inventory of all the possible quantum computing simulators available today. They all have advantages and disadvantages. So of course, every company have their own simulator, which is optimized for their hardware, and then there are more general simulators that can be used.
Okay. Great. So thank you very much. I see there is no more question, and it's just about time for the next speaker. I suggest that during the next speech, you can take a little bit of time to send all the links you mentioned. And yes, again, Alberto, thank you very much for your participation. So that was Dr. Alberto Di Meglio from CERN. And our next speaker, I would like to invite to share the screen with is Professor Sergei Sajin. He's professor of thermal physics at the University of Brighton in the UK, and he's a member of the Scientific Council of the International Center for Heat and Mass Transfer. I hope I made it right, since several years. So he will talk to us about mathematical and engineering modeling of spray. This is, well, far from my area of competence, so I can hardly introduce more, but I'm very impatient to hear you talk, Professor Sajin. Please.
Welcome to my online lecture on mathematical and engineering modeling of sprays. As you can see, the title of this lecture is rather general. And by suggesting this title, I want to emphasize that my focus will be on the general philosophy of modeling, of both mathematical and engineering modeling, rather than on discussing a specific engineering problem of the modeling of sprays. I hope that this philosophy and this approach to modeling could be shared by other colleagues working in other fields of engineering, biological modeling, data analysis, and similar fields. And this is the plan of my lecture. I will start with the background, then I will discuss the meaning of terms, give you a couple of examples of how our approach is realized in practical problems, and then I will focus on one specific problem, namely microexplosions in composite droplets, which is particularly important for engineering applications. When speaking about the background, I will start with a brief overview of a paper prepared by Michael Berry, Emeritus Professor from the University of Bristol. This paper is entitled True But Not Real. And the author tried to focus on two concepts, the concept of true and concept of real. These concepts are obviously different, but sometimes the difference between them is not well perceived by the community. When the first example, which is given in this paper, is the phenomenon of mirage. The mirages can be seen, say, in the desert, but at the same time, they're not true. They can be seen as real, but they don't reflect a true phenomenon. In a similar way, we can consider rainbows. The phenomenon of rainbows was discussed back by Descartes several centuries ago, and he taught us that rainbows are illusions. Here are no colored arcs in the sky. Each raindrop emits light focused into a bright cone, and we looking up see brightly lit only those droplets whose light cones intersect our eyes. So each person can see its own rainbow. So a rainbow is real, but it doesn't reflect the real physics. We see the real phenomenon, but not real physics behind it. At the same time, rainbow physics is true, but it is not real. So we come across two terms, true and real. Real is something that we can see, we can touch, we can understand. True is something hidden from our perception in most cases. And there is a parallel between these two concepts and the concepts of reality and modeling. We don't know much about reality, and the only way how we can perceive it is via modeling. We can't understand each and every detail of reality, but at the same time, we can approach it as closely. We can approach it rather closely by developing more and more sophisticated models. And now we can move to the definition of terms. So mathematical modeling can be defined as a description of the process, engineering, environmental, biological, in terms of mathematical equations. Engineering modeling is also a description of engineering process in terms of mathematical equations. If we use this definition, then mathematical modeling incorporates engineering modeling. But this is not the only approach to the defining of these terms. An alternative approach mathematical modeling is perceived as equivalent of engineering mathematics, and engineering modeling is equivalent of computational fluid dynamics. Engineering mathematics is essentially modeling of individual processes. These could be numerical or analytical. Example, modeling of deformation of individual droplets. Computation fluid dynamics is a focus on modeling of realistic engineering systems. These modeling can be performed only numerically. And example is modeling of diesel engines. These concepts of engineering mathematics and computation fluid dynamics were discussed in length during my previous lectures, and I'm not going to repeat these presentation. But what is important for us is that there is no contradiction between engineering mathematics and computation fluid dynamics. They complement each other. The most constructive and approach to the analysis of engineering systems requires a combined approach using the methods of engineering mathematics and computational fluid dynamics. And this will be illustrated using two examples. One example is focus on fully Lagrangian approach to tracking droplets or particles. The conventional approach, which is used in most research and commercial computation fluid dynamics codes, is based on the so-called Eulerian and Lagrangian approaches, where continuous phase is modeled using Eulerian approach and Lagrangian phase is modeled using and dispersed phase is modeled using Lagrangian approach. At the same time, this approach creates problems when we intend to find the time evolution of particle or droplet densities. And to tackle this problem, a new approach called full Lagrangian approach has been developed. And here are the basic equations referring to the full Lagrangian approach. In what we tried to do in our previous research program is to incorporate the full Lagrangian approach into computation fluid dynamics codes. And ANSYS Fluent was used as a testing ground for these. So here we can see the results of incorporation of this model into Fluent, and it shows the distribution of number density of droplets of various sizes. And this is the reference of the paper where these the details of these incorporation and testing are described. This slide, you can see a comparison between the prediction of the model and the actual observations in internal combustion engines. Here we have the time slots, 1, 1.5, and 2 milliseconds from the start of injection. And we consider time evolution of more than 10,000 droplets with diameters between 1 micron and 30 microns. Another example refers to effective thermoconductivity and discrete component model. So these, in most of commercial computation fluid dynamics codes, a number of simplified assumptions are used. For example, the temperature gradient inside droplets were ignored, And also the droplets were considered as opaque gray spheres. That means that the penetration of thermal radiation and volumetric heating by thermal radiation of droplets were ignored. Also, the effects of diffusion of species inside droplets were not considered. In a series of our publications, we tried to take into account these effects. Moreover, to simplify the problem, we used analytical solutions to both these equations, and these analytical solutions were incorporated into numerical codes. Here we can see the reference to the paper where the results of incorporation of both these models into ANSYS fluid are described. And now we focus on the main topic of our lecture, modeling of microexplosions. Here you can see a typical video of what happens with the droplets, with the fuel droplets in which water is added. The main stimulus of adding water is into fuel, including automotive fuel, is to stimulate droplet disintegration. And the disintegration leads to the rapid evaporation and mixing of fuel vapor and air mixture. Here we can see some images which of microexplosions which were obtained in our experiments. On this image, you can see puffing of droplets, which typically precedes microexplosions. And here we can see properly fully developed microexplosions. And these images were taken from this paper. The most rigorous approach to modeling of the phenomena is based on the direct numerical simulation. Here we can see some examples of these direct numerical simulations taken from the paper by my colleagues Shinyo and others. Direct numerical simulation obviously can capture a lot of fine features of the process which couldn't be captured using any other methods. But at the same time, the picture which you can see would vary a lot if you change slightly the initial and boundary conditions inside the droplet. For example, if you consider the location of water inside the droplet in different places. And also this approach cannot possibly be used in conjunction with the computation fluid dynamics codes, because you cannot incorporate direct numerical simulation into engineering computation fluid dynamics codes. In a series of our papers, we developed a simple approach to describe this phenomenon. And I will start with a very simple model. In this very simple model, it is assumed that a water subdroplet of radius RW is located exactly in the center of a spherical fuel droplet of radius RD. The temperature at water fuel interface is TW, and the temperature at the surface of the droplet is TS. And the heating process of the droplet is described by the heat conduction equation. where the value of kappa thermal diffusivity appears to be different inside the water and inside the fuel. Also, the initial temperatures could be different in the general case inside the fuel and inside the droplet, and you have continuity conditions at the water-fuel interface. At the surface of the droplet, a simple Dirichlet condition was used. In other words, the temperature at the surface of the droplet was fixed. And this equation with these boundary and initial conditions was solved analytically, subject to a number of assumptions. So these are the key assumptions which were used. Firstly, the temperature of the droplet surface is assumed to be constant during the whole period of droplet heating, not just during individual time steps. The effects of droplet evaporation and swelling are ignored. The thermodynamic properties, liquid thermal conductivity, heat capacity, and density, are set at the initial droplet temperature, set at the initial droplet temperature. And then it was assumed that microexplosion starts when the temperature of water or temperature at the water fuel interface is equal to the boiling temperature of water. So using this assumption, the analytical solution was obtained. And this analytical solution is valid for the whole period of droplet heating. And then it was applied to a specific case of droplet microexplosion, which is with the input parameters described in this table. I just want to draw attention that the droplets under consideration were rather small. They were less than their radii were less than 100 microns, and the water content of the droplet was 15%. And then incorporating these input parameters into the analytical solution allowed us to calculate the distribution of temperature inside the droplets at various time instants. And as you can see from this graph, when time instant was equal to 0.5 milliseconds, then the temperature at the water fuel interface becomes equal to water boiling temperature. This model was validated using experimental results. And as you can see, so what we try to validate is the dependence of time to puffing, which leads to microexplosion at various initial droplet diameters. And as you can see, the droplet predicts the increase of time to puffing with the increase of the initial droplet diameter. And this is consistent with actual observations, which can be seen in this figure. This model is described in our paper published last year. And but at the same time, these assumptions which were used in developing the model described in that paper appears to be very stringent, and it would be tempting for us to relax at least some of these assumptions. And this is something that we did in a new simple model of the phenomenon. For example, the assumption that the droplet surface temperature is fixed is replaced by the assumption that the surface temperature is allowed to vary with time. That means that the Dirichlet boundary condition was replaced with the Robin boundary condition. Also, in contrast to the previous model, the effects of droplet evaporation and swelling were taken into account. Also, in contrast to the previous model, the temperature and time dependence of thermodynamic and transport properties were taken into account. And what is most important from our point of view is that the start of microexplosion or puffing was associated not with the time instant when the temperature at the water-fuel interface was equal to the boiling temperature of water, but with the time instant when the temperature at this interface was equal to the nucleation temperature. And this nucleation temperature can be different from the temperature, from the boiling temperature. And in this case, but most of other assumptions of the previous models were still there. For example, there's an assumption that the water subdroplet is located exactly in the center of the fuel droplet is still used in the new model. Also, the new model is based on the same equation for transient heat transfer inside the droplet as in the previous model. In contrast to the previous model, this equation is not solved during the whole period of droplet heating, but it is solved at each individual time step. And the results of the solution were incorporated into the numerical code. And also, in contrast to the previous model, we use not the Dirichlet, but the Robin boundary conditions. And also the effects of droplet evaporations are taken into account. And as a result of these assumptions allowed us to obtain a more general expression for the distribution of temperature inside the droplet at various time instants. And these are given by these formula. I'm not going to describe the meaning of these terms, but they are presented here at this slide. And when this model was applied, to the heating and evaporation, to microexplosion of heated and evaporated droplets. The droplets, which are considered are rather large ones, and the radius of these droplet was equal. Initial radius of these droplet was equal to 1.33 millimeters. And as you can see, for these droplets, we predicted the time to puffing equal to 8.2 seconds. Assuming for the time being that the puffing starts at the time instant when the temperature at the interface of water and fuel is equal to the boiling temperature of water. But now it is we can recall that the actual boiling happens not at boiling temperature, but at so-called nucleation temperature, which depends on the speed at which the temperature at the interface raises. And here we can see the approximation of the dependence on nucleation temperature on the heating rate obtained experimentally. These are different symbols, and also using the approximation which is shown in these by this formula. This approximation is valid in the range of temperature, in the range of heating rates between 100 and 1 million. If this heating rate is less than 300, then a different approximation was used. a different approximation was used. And this approximation is also supported by the available experimental data. Now, to use this approximation, we need to find the values of heating rate at the interface, at the water-fuel interface. And here we have the values of this heating rate for two models, which doesn't take into account the effect of swelling. And now we can obtain two curves. First curve, which is the temperature at the water fuel interface, and this is described by a thick solid curve. Another curve, which is shown here, is a time evolution of nucleation temperature. The nucleation temperature is calculated using the values of heating rate, that is a derivative of temperature with respect to time, and using the correlations which we considered earlier. And on the same plot, we showed the line corresponding to the boiling temperature. And as you can see, there is a visible difference between the time to puffing is described by the intersection of these two curves. The intersection between the solid curve and this one, referring to nucleation temperature, gives us the corresponding value of time to puffing. And the intersection of the solid curve with the line corresponding to boiling temperature will give us slightly smaller value of the time to puffing. And these values are equal to 8.5 and 8.2 seconds, and they need to be taken into account in refined analysis. And unfortunately, there is not a good agreement between experimental results and the prediction of the model. The model predicts smaller time to puffing. And this is attributed to the main limitation of the model, that the water droplet is located exactly in the center of the fuel droplet. If it is located off-center, then the time to puffing would be much less than the one predicted by our model. And the results, preliminary results, were published in our early papers, published early this year, and the full description of the model is given in our recent paper submitted for publication in International Journal Heat and Mass Transfer. And these are the funding bodies which are supported this research. And I thank you for your attention. Thank you very much.
So again, thank you. Great talk, very interesting. I will just go through the questions quickly. We are unfortunately running out of time, but it's the last talk, so so there is a first one that I see less as a question, so I'll read it out loud for everyone. So, dear Sergey, thank you so much for the bright and very informative presentation. It would be very useful to publish it even from a methodological point of view. A philosophical view may be more important than specific results. So here we are. And the next one would be, thank you for your interesting presentation. Do you know how much time takes a simulation on fuel injection in an engine and what computers or clusters are used? So, Professor Sajin, please, if you want to answer to that. Okay, I think you should maybe turn on the microphone. We don't hear you. That would be top right corner, just in case. Okay, or of course he can answer using the chat. Absolutely. So I'll do the following suggestions. Since we won't have an oral answer, we will proceed like the last time. So of course you can keep writing in the chat, and I suppose you will get answer for your questions. And for the rest, we will of course address all the questions and answer them later if we could not answer them on the chat. And I will cut the video broadcasts now. So actually, I will now close the plenary section for today, and therefore for the whole conference. Thank you again all for your organization, for your participation. Thanks to the organizing committee to offer me to be a chairman today. It was fantastic to see those really strong international links in action, even given the global situation. I'm well aware of the great organizational challenge that was necessary to achieve the transition to online content. We will wait for you, of course, at the section talk and at the closing ceremony a little bit later. As general information, the planning will now go as follows. So we will have 23 minutes break until 1 o'clock Samara time, so 12 o'clock Moscow time, and 11 o'clock Central European summertime. Section talk will start again at this time, and they will continue until 3:30 Samara time, so 2:30 Moscow time, and 1:30 Central European summertime. It will be followed by a 30-minute break again, and the closing ceremony. The closing ceremony will start at 4 p.m. Samara time, which is 3 p.m. Moscow time, and 2 p.m. Central European summertime. So thank you all. Thank you to the speakers and all our participants.